And at this, I don't really have a clear view of this, do I? What do I need to do? This doesn't show me anything, Chelsea. But I might see something if I do what? Yeah, change the window. Well, in what direction do I need to see more window? Yeah, so let's, we can do that. I've been doing this for you. I just go on and open up a text box there. I would hope people wouldn't go 100 miles an hour. I would hope. Let's assume that it's only like 60. And let's see what happens. Oh, did that work? Do I see something now happening? Yeah. So I don't have to go to, 1,000 or something. And by the way, it wouldn't make any sense. We don't have cars that go 1,000 miles an hour. But I do see something happening here. Now, what I want to know is that, and there's a peak there, isn't there? At that peak, what input value do you think's there? I would kind of guess that, yeah. I'm changing the window here also to kind of get a better view of this. I would hope that at that peak, something is happening with the, that's about square root of 1100. So, you can do a few things there. One is, and I don't know if this is available to you with press to test, so be very cautious. Be sure that you can do this in other ways, like placing the point. We've been doing that so much, though. And I'm just going to open that up, and that looks pretty encouraging to me. Okay, what was our approximated value of the square root of 1100? Okay, and if I hover, remember, if you hover there and then press the plus sign, you can get more digits. How does that compare to that approximated value? Pretty good. Pretty good. Okay? So, what's our conclusion? This is where my favorite question comes in. So what? I find that at this value, the second derivative is, not greater than, less than. Therefore, traffic flow is maximized when cars travel fast. Approximately, yeah, you don't want to say exactly, but approximately 33 miles per hour. What does that tell you then? You're driving in Chicago, Casey. You get into one of these traffic jams. What's the tendency for most people? You ever watch them? Speed up, and then they just slam on their brakes as the car ahead of them has stopped again. And they just keep speeding up and stopping. Have you ever watched the semi-trucks? What do? They chug away. Now, there's a couple of reasons why they do that. They have so many gears they have to go through that it's harder for them to keep, shifting in and out. So they stay in one gear. Do they go 60 miles an hour? Do they try to speed down that? No, they go at a constant rate. I had a little car once that had a manual transmission. I don't know how many of you have ever driven a manual transmission. I love that little car. If you've never driven a manual, it's pretty cool. You feel a little power there, as you're speeding down. Anyway, so I get into Chicago. I was going through there. And all of a sudden, I get into one of these traffic jams. And instead of trying, because in a manual you have to kind of keep shifting gears, and it's a hassle, But I put it in first gear, and I just kept it there. Now, was there a space in front of me? Yeah. What did some other drivers do? Zoom in front of me. Okay, well, that's their problem. But I kept going at that constant. I never had to brake. Never had to stop. What this problem is saying is that if in that situation everyone would just slow down and go about 30 miles an hour on this roadway, maybe not on yours, but on this roadway, everyone would be able to just keep moving. They would never have to put their brakes on. They wouldn't have to be shifting down in gears or whatever. It's an interesting thing, and I actually had it happen, and it worked on that trip. So think about it the next time you're on one of those busy roads and you get into congestion. Just back off, let the crazies do their thing, and just keep moving along at a steady speed. Okay, you see how math applies to your life? You'd never think of that. Okay. You know, we've had open box problems forever. Haven't you had that open box problem back in Algebra 1? Okay. Let's see what else. Find the largest isosceles triangle that can be inscribed in a circle of radius 4. This is more interesting. The largest isosceles triangle that can be inscribed in a circle. Now, my circle doesn't look very much like a circle, does it? There's a little oblong here. Let's see if I can correct it a little bit. Deal with it, okay? That's about all I can say today, deal with it. It's supposed to be a circle there. So on your paper, draw a better circle than mine. There we go. I found a new tool. Okay. There's a circle. Now, isosceles triangle. Isn't it a circle? Okay. Isosceles triangle. What do you know by an isosceles triangle? Is it all sides or all? Ah. Two sides, yes, two sides have the same value in there. Okay, have the same. So I need to draw a triangle. Let's see if I can use my magic tool again. You like that magic tool? Isn't that neat? Yeah, much better than mine, isn't it? Okay. Oops, let's bring that up there. Okay, so there is our drawing. Now, it almost looks like maybe it's isosceles, but we'll assume that it's, that's equilateral, but we'll assume that it's isosceles. Can you describe in a circle of radius 4? What's a radius? And how would I draw it on here? Center of the circle. Where should I draw that? I'll assume the center is right about here. Would that help me at all? Probably not the best place. So think ahead. Where do you think I should draw this so that it looks like it's going to help me? Probably to one of the vertices. Because if I draw from here to the vertice, okay, then I love this. Then it might help me out. Okay, so we draw this. It says solve by writing the area as a function of h. Now, when we look at h, what are we considering? Now, I'm going to draw this up here too. I'm going to draw it over here also. Okay, because if I'm looking at this triangle and I want function of h and I want area, find the area of the largest, let me highlight that to make sure we don't lose what we're trying to do, the area of the largest triangle. So what am I trying to maximize? Area of a triangle. Yeah, okay. So all I need is a formula for the area of a triangle. So if I know that, and we do, it's 1/2 base times height. And it says write area as a function of h. What would you like me to draw here as the as h? which of these segments would we probably want to see as H? Any of them? What is he saying no? Which one, or what do I need to do then? You said I can't use any of these, so what should I use? Pardon? Okay, so if I took this and extended it down, okay, then the area, the height would be this whole thing, okay? So, let's see. The height is this whole thing. How can I use the information up here to help me out? This is how much? 4. Okay. Let's see. I'm going to make this point P. I'm going by what I have on my diagram here just so I can look at something. I made that point B here, so point B is the point where it intersects, or it's perpendicular to the base. And let's see, I made that one D, and I know that this is equal to that from geometry. I know this is 4. I know that is 4 also. So I need to find the area of triangle ABC. H is this. According to my notes, what did I do?
Does at the bottom 2 radiuses that you have drawn, does it not make a triangle with the base of the other one? They're both 4, so then you figure out the other one.
Okay.
Find the height of that triangle.
Okay. So what I actually have on mine, and I think I'm going on what you said also, I made H be that little extension down here. But when I'm talking about the height of this big triangle, so the area of ABC, my height is going to be 4 plus H. Okay. Now, what about the base? So we'll leave that there just to kind of go by this. This is 4 plus H. So we'll put H here in parentheses so we don't mistake it to be the H that we have here. Okay. What about the base? How can we go about finding that? Yeah, Corey? Casey?
Square root of 16 minus h squared.
Whoa, how did you do that? Square root of 16 minus h squared. Okay? How did you do that? And you did that because you let small letter b from here to here. Well, that makes sense then, doesn't it? Okay? So, again, these auxiliary lines are what we, if we think about it and put all of our knowledge of geometry into play, okay? Don't be afraid of labeling. So some of these that you're going to have, don't be afraid of labeling and coming up with this. So this little triangle down here now, which would be PBC, will give us this. Is that going to be the same as the base of our, and we better put that in parentheses too. I mean quotations too. So what is this going to equal? 2 times that, okay? So this is going to be 2 times the square root of 16 minus h squared. Okay. Are we clear on this? Let me do this for us. This is the base, and this is the area of triangle ADC. Okay, and this then is, and we'll dismiss with those quotations now that we've got this information. Okay, so we know that small case b is here, and so the base of this whole triangle